Hello guys, this video is about Laplace of derivatives and we'll be referring to the basic table of Laplace transforms for all our examples. Now, Laplace is a process that transforms a function in the time domain into a function in the Laplace partial domain. The theorem of Laplace of derivative implies that the Laplace of the first order derivative, which is f prime t, is equivalent to s multiplied with the Laplace of the function itself, which is Laplace of ft, minus with the initial value of the function itself in the time domain when t is equivalent to 0. In other words, this is equivalent to S capital Fs minus with small letter of f0. And I would like to highlight here that the capital letter of f here is referring to the function in the spatial domain, whereas the small letter of f here is referring to the function in the time domain. So let us just be clear on these two differences. Now, by referring to the above function, we can derive the Laplace of the second order derivative, which is the Laplace of f prime prime t. Now, similarly, this is equivalent to the variable s multiplied with the Laplace of the first order derivative, which is f prime t, and we should minus this with the initial value of the first order derivative, which is f prime t when t is at time 0. Now we can summarize this is as equivalent to s multiplied with in bracket, if we look, Laplace of the first derivative is equivalent to s times capital letter of fs minus with small letter of f at time 0, and the whole lot is minus with the initial value of the first order derivative at time 0. Now, if you're wondering how do I derive this, let's have a look at what is the definition of the Laplace of f prime t. So we substitute this into here. And let's not forget to bring the negative initial value of the first order derivative at the last part. So now, the whole formula we can summarize as Laplace of the second order derivative as equivalent to s squared multiplied with the function capital Fs minus with s multiplied with the function f at initialized at time 0 and minus with the initial value of the derivative at time 0. Now guys, again I would like to emphasize here that the capital letter of f here is referring to the function in the spatial domain, which is the Laplace in the spatial domain, whereas the small letter of f here is referring to the initial value of the function in the time domain, and f prime here is referring to the initial value of the derivative also in the time domain. Now that we know the theorems, let's start with an example ft, which is equivalent to exponential to the power of t. Now, based on the basic Laplace transform table, we know that this function has a Laplace transform of 1 over s minus 1. Now, we also know that ft has a derivative, which is f prime t, which is equivalent to exponential to the power of t. In other words, they are identical. So here we'll try to verify that the Laplace of the derivative, which is f prime t, must also be similar to the Laplace of the function itself, which is ft, whereby both of them should have a Laplace transform of 1 over s minus 1. Now, based on the theorem of the Laplace of derivatives, it says that the Laplace of the function of the derivative, which is f prime t, is equivalent to the variable s multiplied with the function in the spatial domain, which is f capital S, minus with the initial value of the function in the time domain, where t is equivalent to 0. So now here, we can also replace this f of s with 1 over s minus 1. Now, how do I derive this? Is from the Laplace of ft here, which is also equivalent to the function f of s, capital F of s, in the spatial domain. So we substitute this value here. So this is how we derive this. And let's not forget that the whole equation, we minus it with the initial value of the function itself in time domain when t is equivalent to 0. So now from here, let's try to substitute these values. What we will have here is the initial value of the function when t is at 0 is exponential to the power of 0, and that is 1. So we substitute here into the overall equation, and we will get s, which is s over s minus 1, minus with everything in bracket s minus 1 over s minus 1, so it is basically equivalent to 1. So now when we solve this equation, we will get s minus with s plus with 1 over s minus 1, and we can cancel out the two variable s from the top equation, and we are left with the answer 1 over s minus 1. So basically, we have verified that our answer is 1 over s minus 1. So the Laplace of the derivative is similar to the Laplace of the function itself. Therefore, it is verified. That's it for this video. Thank you.